Hello students, welcome back. We completed section 1. Now let's go to section 2, dot product. Or in other words, the inner product or the scalar product. All these terms are interchangeable. The dot product, the inner product, or the scalar product. They all mean the same thing. Well, let's stick to our textbook author's terminology, the dot product, at least for now. And here's a definition. The dot product of two vectors form a scalar. v1 times v2 is the magnitude of v1 times the magnitude of v2, both are scalars, and then cosine of theta, where the angle theta is as pictured here, the angle between those two vectors. Now the previous vector operation, the addition and scalar multiplication, were universal. They apply every single time. But this one here applies only when there's an angle. Wait a minute. Angle always exists, don't they? Well, in two-dimensional space, yes. In three-dimensional space, a bit harder, but yes. Four-dimensional or higher, it's already hard. Now, infinite-dimensional, then, of course, it's impossible. So, the angle here can be a bit tricky concept. So is there any way to get around it? That could be something we have to consider. In any case, for now, we define vectors like this, and that's why we consider vectors in trigonometry classes a lot. It's related to a trig function. Another way to express the same thing turns out to be this when you have component expression. So multiply the x-coordinate, x1 times x2, and multiply the y-coordinate, y1 times y2, and then add them up. Now, are these the same? Well, that's a big question, and the proof of that is something I go over as a final project of trigonometry class, and I'm going to leave it as an exercise for week 1 in Calculus 1. So multiply the x-coordinate and multiply the y-coordinate and then add them together. And there gotta be some sketch of hint or something like that. Yeah, okay. V1, V2, and here's the angle. And then if you take the subtraction of the two, V1 minus V2, we get the green vector. So V2 plus this green, V1 minus V2, then I'm gonna get the straight red. Make sense? Starting point, the final point, straight ahead, then that's V1, red. Now V2, and then V1 minus V2. That's gonna be the same as V1. Now here, we can apply the law of cosines. The magnitude of green squared is the magnitude of red squared plus blue squared minus 2 cosine of theta. This one here, the law of cosines. Remember this? And then this V1 times V2 times cosine of theta, that's a dot product. So you can solve for this dot product, flip all these over to the other side, subtract this away and divide by 2, and then work out some computation using Pythagorean, horizontal squared plus vertical squared for red, using Pythagorean, horizontal squared plus vertical squared for blue, and then again Pythagorean, horizontal squared plus vertical squared for green, and then work out some algebraic manipulation, eventually simplifies into this. A bit hard to follow? Okay, if you cannot follow, just remember the result. If you do understand the process, that's great. And this is just a sketch. This is, after all, Calculus 1. It's not a proof-based mathematics course, so I'm not going to overemphasize the reasoning. But everybody should know the result. The dot product in trig form, magnitude times cosine of theta. The dot product in component form, multiply the x-coordinate and multiply the y-coordinate and add them up. These two definitions are equivalent. And the proof, okay, all right, if you remember the law of cosines, great, but otherwise, just remember the result. How do you apply those? Well, one example is finding angles between two vectors. Ooh, excuse me. I didn't want to show you that much. Find the angle between these two vectors. 2, -4 and -1, 2. Well, remember this. Set these two equal to each other. So v1 times v2 times cosine of theta is v1 times v2, but that's x1, x2 plus y1, y2. And then we don't need this part. Never mind. Let's keep it here. And then one more. Square root of x1 squared plus y1 squared for vector 1. And square root of x2 squared plus y2 squared. Cosine of theta is, x1, x2 plus y1, y2. So compare this and that. The left-hand side is this Pythagorean expression for v1. And Pythagorean expression, the same for v2. And the right-hand side, v1 times v2. So blue, red, respectively. Okay, we are ready. Plug those in. 2, -4. And -1, 2. Let's use Pythagorean. The distance from the origin. So 2 squared plus -4 squared. That's blue. -1 squared. Oops. Sorry about the typo. Plus 2 squared. That's red. I'm speaking and writing at the same time, so I frequently make the typo. Sorry about that. Now 2 times -1 plus -4 times 2. And the right-hand side is easy. So it's -2 minus 8. That's -10. Is that right? So cosine of theta will be -10 divided by the square roots. Divided by the square root of, let's see, 4 plus 16, so square root of 20. And 1 plus 4, so square root of 5. Is that right? Can that be simplified? Let's see, this is 4 times 5, so -10 over 2 square root of 5, and then another square root of 5. So -10 over 10, that's -1. Cosine of theta is -1. So the angle theta has to be pi, 180 degrees. check your computation. The first dot product and the second dot product are the same. So trig expression on the left hand side, component expression on the right hand side. And then put all those numbers in. Pythagorean for magnitude, blue and red. That's the left hand side. And the right hand side, multiply the x coordinates, multiply the y coordinate, and add them up. Alright, put all those numbers in. 2, -4, -1, 2. Do your computation. Right hand side is easy, -10. And the left hand side, put those numbers in, then square root of 20 and square root of 5 respectively. So square root of 100. 20 times 5 is 100. Square root of 100 is 10. So -10 over +10, so it's -1. Cosine of theta is -1. You're going to get angle pi. Well, here we go. Indeed, you have angle 180 degrees. Here's a visualization. Okay, how about the next problem? Well, I'll leave you there. Do your computation, set these two equal, this equal to that, and then put the numbers in. If you do it right, this time you're going to get cosine of theta equal to 0. This time I want to save some time, so let me give you this. The dot product computation using component divided by the Pythagorean computation, you're going to get 0. So cosine of 0, so that's pi over 2, 90 degrees. Well, here's a visualization. Does it look like 90 degrees indeed? Of course, in general, you'll have to use calculator for that. Let's see. Previously I had this. Yeah, okay. And okay, let's suppose I have something different. Change the problem a little bit. Okay, keep this the same. And then this is -3, so -6, and I only get -8 this time. And this is -3 squared. So 4 squared plus 9, so is it 13? So 5 times 13, that's what? 75? No, 65. In that case, you'll have to do your inverse cosine computation. And if you punch into calculator, you're going to get something. So this is a general case. The case we did earlier, perpendicular and opposite, those were extremely simple cases. In general, prepare to use calculator. Okay, so much for the first half. Let's come back to the second half in the second video.